Okay, here we've got a question where we're trying to find the formula of the hydrated magnesium bromide. In other words, we're trying to find the value of X, or the number of moles of water of crystallization, or number of moles of water of hydration in a hydrated compound, magnesium bromide, MgBr2.XH2O. Don't forget that the dot is nothing to do with multiplication. It just means that there are a certain number of molecules of water bound in the crystal to 1 mole of magnesium bromide. Okay, you can almost think of it as being an addition, right? They're added to, they're in that solid. Okay, there are 2 ways actually to go about this problem. Perhaps the simplest way is just to go about it as if it's an empirical formula problem. And if you remember, with empirical formula problems, we set them out in a nice table to begin with. So, we already know what the formula of magnesium bromide is. It's MgBr2. And we're trying to find the ratio magnesium bromide to water. So let's set that out like that, and then set the table as we would with empirical formula calculations, the mass in grams followed by the relative molecular mass, and then we're going to find the number of moles. So the molar mass of magnesium bromide, if you calculate that now, just pause. Okay, you've found that out, and I hope that you've found that the molar mass of magnesium bromide is 184.11 from your data booklet, your IB data booklet, and water is 18.02. The mass in grams of the magnesium bromide is given in the question as 4.60. That's anhydrous, without water. That's just magnesium bromide, but that's 4.60. And the water, well, the water is found by subtracting the 2 masses, because the 7.30 grams is the mass of this, and that includes all the water. The 4.60 grams is just the magnesium bromide. So if we subtract one from the other, we get the mass of the water which is released in the experiment, 2.70. And if we divide the mass by those relative molecular masses, we get the number of moles, 0.0250. Might be a good idea to pause and just check you can do those calculations. If we then divide by the smallest being this one, 0.02050, divide it by itself, and divide this by 0.0250. So we've got number of moles, and divide by smallest. That gives us a ratio of 1 to about 5.99. Of course, the value of X must be a whole number or an integer, so we can see that the value of X must be 6. So there are 6 molecules of water for each magnesium bromide unit. Now we can do that question in a slightly different way, and sometimes you might be asked to do it by finding out the relative molecular mass, or the formula mass, of the hydrated salt. Now remember that magnesium bromide H2O undergoes this change when heated. So we can write that balanced chemical equation. And again, the information in the question, we're given 7.30 grams of the hydrated salt, and it gives us 4.60 grams of the anhydrous salt. Well, the trick here is to remember that the equation is the stoichiometric equation. It gives the ratio of the reactants and products. 1 mole of magnesium bromide .XH2O gives us 1 mole of magnesium bromide. So if we work out the number of moles of the anhydrous magnesium bromide, it's 4.60 divided by its molar mass, again found from the periodic table, it gives us 0.0250 moles. Now, that means that the number of moles of the hydrated salt must be the same, because we've assumed it's all been converted to magnesium bromide in a 1-to-1 ratio. So that is also equal to 0.0250 moles. Now, remember that the number of moles is equal to the mass divided by the molar mass. So for the hydrated salt, we now know the number of moles, it's 0.0250, and we know the mass, it's 7.30 grams. So if we now work out the molar mass, it's 7.30 divided by 0.0250, we get about 292. So we know the molar mass, so we can form a linear equation. And x tends to r plus however many moles of water in the salt is equal to 292. I'm going to move up here, excuse me, I've run out of space. So now we know, if we form that linear equation, that 184.11 plus 18.02x equals 292. If we solve that, we find that x is equal to 292 subtract 184.11 divided by 18.02, which is nearly 6. We get the same value. Either way can be used if you're not told. However, you might well be asked to work out the molecular mass of the compound before finding the value of x. So then you would need to use this method. Thank you very much.